I went to school with a lot of the people that now build these technologies. I went to school with some of the executives at OpenAI. I don't find these figures to be towering or magical. Like, I remember when we were walking around the dorm rooms together in our pajamas, and it instilled in me this understanding that technology is always a product of human choices, and different humans will have different blind spots. And if you give a small group of those people too much power to develop technologies that will affect billions of people's lives, inevitably that is structurally unsound.
Artificial intelligence is the backbone of some of the biggest companies in the world right now. Multi-trillion-dollar companies can talk about nothing else but AI. And of course, whenever it's discussed in the media by politicians and civil society, it's compared invariably to the steam engine.
And that kind of that marketing route to the phrase is part of why it's really difficult to pin down a specific definition today. The other reason is because generally people say that AI refers to the concept of recreating human intelligence in computers, but we also don't have a scientific consensus around what human intelligence is. So quite literally, when people say AI, they're referring to an umbrella of all these different types of technologies that appear to simulate different human behaviors or human tasks. But it really ranges from something like Siri on your iPhone all the way to ChatGPT, which behind the scenes are actually really, really different ways of operating. They're totally different scales in terms of the consumption of the technologies. And of course, they often have different use cases as well.
So right now, when OpenAI, Meta, when they use those words AI in regards to their product. So right now, when OpenAI, Meta, when they use those words AI in regards to their product, specifically, what are they talking about?
Most often, they are now talking about what are called deep learning systems. So these are systems that train on loads of data, and you have software that can statistically compute the patterns in that data, and then that model is used to then make decisions or generate text or make predictions. So most modern day AI systems built by companies like Meta, by OpenAI, by Google are now these deep learning systems.
So deep learning is the same as machine learning? It is the same as neural networks?
Deep learning is
these all synonyms?
Deep learning is a subcategory of machine learning. Machine learning refers to a specific branch of AI where you build software that calculates patterns in data. Deep learning is when you're specifically using neural networks to calculate those patterns. So you have what I call patterns. So you have what I call one of the founding fathers of AI used to call AI a suitcase word. So because you can put whatever you want in the suitcase and suddenly AI means something different. So we have this suitcase word of AI. And then under that, any data-driven AI techniques are called machine learning. And then any neural network data-driven techniques are called deep learning. So it's the smallest circle within this broader suitcase word.
So deep learning and neural networks are kind of interchangeable.
Not exactly, in the sense that neural networks are referring to a piece of software and deep learning is referring to the process that the software is doing.
Right.
Yeah.
Do you get upset when politicians, so in this country we have a prime minister called Keir Starmer, and they say, we think the NHS can save, 20% by, using AI applications.
Right.
Do you sort of think, my good, like these people have no idea what they're talking about because that is such an expansive term. It can't really, its political convenience is precisely, it doesn't mean anything.
It does frustrate is that the resource consumption required to develop these models and also use these models is quite extraordinary. And oftentimes people are using them for tasks that could be achieved with highly efficient, different AI techniques. But because we use this sweeping term AI to mean anything, then people just think, oh yeah, right. I'm just going to use ChatGPT for my one-stop shop solution for anything AI related.
So right now, data centers globally, I think, are about 3.5% of CO2 emissions. I think the data centers for AI are a tiny fraction of that, but obviously they're growing at an extraordinary pace.
Yeah.
Are there any numbers out there with regards to projected CO2 emissions of data centers globally 5, 10, 15 years from now? Or is that also, it's so recent that we can't really speculate about the numbers involved?
There are numbers around the energy consumption, which you could then use to kind of try and project carbon emissions.
Zone intelligence, more plausible. Who are the major players in that field right now?
One caveat on AGI is that it's as ill-defined as the term AI. So I like to think of it as just a rebranding. You know, the entire history of AI has just been about rebranding, and the term deep learning was also a rebranding. So anyway, but the players, OpenAI, of course, they were the ones that fired the first shot with ChatGPT. Anthropic, major competitor. Google, Meta, Microsoft, they're the older internet giants that are now also racing to deploy these technologies. Super safe superintelligence, which spun out of also an OpenAI splinter. There are many OpenAI splinters. So this was founded very recently by the former chief scientist of OpenAI, and Thinking Machines Lab, founded very recently by a former chief technology officer of OpenAI. And Amazon is now trying to get into the game as well. So
in regards to the deep learning, give me a sense of the scale. We've talked a little bit about the data centers, but how much energy, land, water is being used to power OpenAI? Just specifically as one company.
Yeah, to power Open, that's really hard because they don't actually tell us this. So we only have figures for the industry at large and the amount of data centers.
So it's not in their annual reports, for instance?
No. Well, they don't have annual reports because they're not a public company.
Of course.
Yeah.
Huh.
So that's, one of the ways that, and actually, it doesn't matter if they're a public company because Google and Microsoft, they do have annual reports where they say how much capital they've spent on data center construction. They do not break down how much of those data centers are being used for AI. They also have sustainability reports where they talk about the water and carbon and things like that. But they do not break down how much of that is needed to create powerful AI models. So there were interesting papers that I wrote about where you could have a couple hundred images to create highly performant AI systems, or you could have AI systems trained on your mobile device. That's like not even a one computer chip running on your mobile device. And OpenAI took an approach that is now using hundreds of thousands of computer chips to train a single system. And those hundreds of thousands of computer chips now are consuming, city loads of energy. And so if we divorced the concept of AI progress with this scaling paradigm, you would realize then you can have housing and you can have AI innovation. But once again, there's not a lot of independent experts that are actually saying these things. Most AI experts today are employed by these companies, and this is basically the equivalent. It's a Chinese AI model that was created by this company, Highflyer, and they were able to create a model that essentially matched and even exceeded some performance metrics of American models being developed by OpenAI and Anthropic, with orders of magnitude less computational resources, less money. That said, it's not necessarily the perfect. It's like I don't think the world should suddenly start using DeepSeek and saying DeepSeek solves all these problems, because it's still engaged in a lot of data privacy problems, copyright exploitation, things like that. And some people argue that ultimately they were distilling the models from that were first developed through the scaling paradigm. So you first develop some of these colossal scaling models, and then you end up making them smaller and more efficient. So some people argue that you actually had to first do that scaling before you get the efficiency. But anyway,